This is week 5 and this is an example of problem 7. A business student is searching for a used car to purchase. So she posts an ad to a website saying she wants to buy a car between 18,000 and 20,000. She learns that there are 150 cars matching that description within a 30-mile radius of her home. Assume that those are the people who will call her and that they are equally likely to call her. We're asked to calculate 4 different values. Now this is the table that we got. There are 6 makes of cars and the numbers that fall within 2 price ranges are shown and the total is also indicated. What is the probability that the first caller will own a car of make D? Now the probability again is going to be equal to the number of successful chances or opportunities divided by the total number of opportunities. The grand total for D, how many cars do we have for D in total, is 20 plus 6, so that's the number of cars we have with D type, and the total number of cars is listed here as 150. So the probability that it's D is going to be equal to the number of D cars that qualify divided by the total number of cars, which is going to be 0.173. Now moving on to part B, and I think this belongs here. What is the probability that the first caller will own a car of model D that costs between 18 and 18,999? Now the probability you're looking for is for 2 things to happen, for it to be D and for it to be within this range. So we're looking for the intersection of this as well as this row here, this column. So therefore the total number that qualifies as in D cars between 18,000 and 18,999 would be 20, and the grand total, now the grand total we're looking at is, let's read the question again, what is the probability that the first call will own a car of make D that costs between 18,000 and 18,900? Now that's gonna be equal to, the grand total is gonna be equal to the 150 cars, because we're looking at the first call being a joint event, but the total possibilities is really any one of the 150 callers or potential callers. So the probability that it's that joint event will be the probability of the joint event divided by the total, which is going to be 0.133. Now moving on, part C, if the first call offers her a car of make D, what is the probability that it will cost less than 19,000? Now the probability that takes into account a given condition is called a conditional probability and is given by this formula here. So the probability of B given A is the probability of A and B divided by the probability of A. Now if we wanted to find the probability that is less than 19,000, given that it's a make D, then we need to find the probability that is a make D and less than 19,000, and then we're also going to need to find the probability that is a make D. So looking at the table, what's the probability that is a make D and less than 19,000. That's gonna be equal to this here, which is what we found, that it owns a car. That's what we found in that part, so we can just go ahead and substitute that probability, and that it's the probability that it's a make D is what we found in the first part. So we have those two values. The probability that it's less than a 19,000 car given it's a make D, we would utilize that divided by that, which is the probability that it's a make D and less than 19,000 divided by the probability that it's a make D, and that works out to be 0.769. Another way you could look at this, just to look at it rationally, if we want to find the probability that is less than 19,000 given it's a make D, it means we're only interested in this cell, and the probability that is less than 19,000 would be, successes would be 20, and the total possibilities would be 26, right? And that gives you the same figure, and it's just a different way of looking at this and understanding what conditional probability is all about. With conditional probability, our total becomes what is given. So the make D, that's a given, so we're no longer considering, for this part, we're no longer considering anything else in any other make. We're only considering D's, and that's a total of 26. And then for the numerator of that probability, we're looking at the ones that are less than 19,000, which is a possibility of 20. So 20 is the number of successes, and 26 is the number, the possible number that it can pull from. Part D is asking us, suppose she decides to ignore calls with cars that cost greater than 19,000. What is the probability that the first call she will take will offer to sell her a car that is of make D? Now again, that's a conditional probability. We're looking at the probability that it's a make D given that it's less than 19,000. So we need to find these two expressions, the first of which is the probability that is less than 19,000 and it's a make D. So if we wanted to find that, then that's going to be equal to the probability that it's a make, it's less than 19,000 is going to be in this column, and it's a make D, so that's 6, and you divide that by the total number, so that's that probability. And the probability that is less than 19,000 is going to be, how many ways can it be less than 19,000? And this is the total, and you divide that by the grand total. And then let's look back at this, because I think I made a mistake here. The probability that is less than 19,000 and it's a make D should really be not column C, because we're looking at less than 19,000. So it's 20, which is here, is less than 19,000, and it's a make D. So this is supposed to be equal to 20 divided by 150. So therefore the probability that it's a make D given it's less than 19,000 is going to be equal to, and again let's look at it the other way, the probability that it's less, it's a make D if it's less than 19,000. We again are looking at this set of data. So the probability that is make the successes in this possibility would be 6, and the total number of possibilities for less than, no, I'm sorry, the successes would be 20 because we're looking at less than 19,000, and the total possibility would be 92. So those two work out to be the same. So it's just a different way of looking at how to calculate conditional probability, and both of them will lead to the same response. Alright, so this is week 5, problem 7, and thank you for watching.